All right, welcome back. We're looking at an extension off of Chapter 5, Lesson 3. So, as we've previously have learned in the past three lessons, a system of equations can be solved by either graphing, substitution, or elimination. So we really looked at three different methods so far, okay? And it really doesn't matter which of these three you choose. If you choose, oh, I have the new pen, so see, look, it has this cute little plastic thing, so I can't use it. Okay, here we go. I think it should work now. So, graphing, substitution, and elimination. So, whenever you have a systems of equation, whether you use one or the other, you will end up with the same answer every single time. But depending on the system of equation that you're using, choosing one is wiser than choosing the other. And I say that only for your own particular ease of solving the problem. Sometimes the way that the system of equation is set up, it's easier to find the solution by graphing. But other times the way that the system of equations is set up, it's easier to solve by substitution and also by elimination. So we're going to look at some different examples and just kind of get into the strategy. When you have an example, what would be, is it best to graph that one? Is it best to substitution? Or is it best to use elimination just for the ease of your own solving, pretty much? So let's look at some different strategies. So the first one is use graphing if both equations are solved for y, or if you want an estimate of your solution. Okay, so if you have two equations and they're already solved for y, I mean, it's pretty easy. I mean, you can still graph if something's not solved for y. You just have to like solve it algebraically for y, then graph it and put it in slope-intercept form. However, if you have both equations that are solved for y, then boom, it's pretty easy just to graph those and find out what a real quick solution is. However, sometimes if it doesn't just end right on that hash mark, or if the solution is some type of decimal or fractional number, then it might just be more of an estimate than an exact. Sometimes you'll graph it and it'll be like really, really obvious, and so it'll be an exact answer, but it could also be kind of like an estimate where if it was a decimal, I mean, is it 2.34? Is it 2.38? You don't really know. You're just kind of looking at it and eyeing it. That's why it's an estimate. But other times it will be very, very obvious. So yeah, use graphing when they're both solved for y. Okay, then the other option is substitution. Now the strategy for substitution is use substitution if either equation is solved for a variable. Okay, so that's like the variable's already isolated, like it's y equals and then something, or x equals something, then boom, use substitution. Or use substitution if the variable has a coefficient of 1 or -1. So sometimes if it's not solved for x or y, but the variable in front of the x or y is just 1 or -1, then it's pretty easy to solve it for x or y. So substitution is a good tactic to use. Okay, and then finally, elimination. Use elimination if both equations have the same variable with the, use elimination if both equations have the same variable with the same or opposite coefficients. So they have the same variable, like you have 3x and 3x, right? Or ideally it would be 3x and like a positive 3x and then like a negative 3x, where those variables can eliminate and then you just be left with y's. So this is kind of the strategy, and we're going to be applying this strategy as we look at a variety of different examples. Okay, so also, just a side note, it may be necessary to manipulate your equations to get them in any of the three forms. So know that manipulate just means algebraically moving like a variable or a number from one side of the equation to the other. That's what this statement is saying. So what do you guys see for this first one? Let's look at this system of equation. What do you think? Should we solve it by graphing, substitution, or elimination? So this little bubble says, if you said both equations are solved for y, use the graphing method or substitution. Okay, so either of those methods, okay? So it's solved for y, so super easy to graph. We'll try that. But also with them both solved for y, it's easy to solve using substitution as well. So let's just go ahead and do that. Okay, I got some fun new colors, so I think I'm going to use them. All right, this is like fuchsia. I like fuchsia. Okay, so this first line, right, to graph this, first we'll do it by graphing. Okay, so y-intercept is 2, and then there's the slope is, there's 1, right? So this is going to be 1 over 1. Okay, so up 1 over 1. And a lot of times I like to make these points because when I make these points, then, you know, on the graphing when it was talking about whether it's a estimate or the actual answer. When I have these points and then like 2 points line up with 2 other points, then I know it's not an estimate. I know it's like and it's an exact answer, if that makes sense. Hopefully this problem you'll be able to see what I'm talking about. Okay. Okay, so that's the first line. If what I just said didn't make sense, which is very possible. Okay, I'm gonna use this. Well, I feel like that goes with this blue. It's so hard when you have so many. I got some new colors. So look at my new colors I got. I got this one, this one, this one. Different shades of purple. I really like purple. Now I have 2 shades, different shades of blue. And then just families of orange. I'm not sure how the orange is going to show up. But this is just kind of unveiling my new colors I'm going to be using. Okay. So I'm trying to think. Maybe this purple. No, I don't know. It's just so hard to choose sometimes, you know? You think you're going to go in. I'm going with purple. I don't know. I just kind of like purple. Okay, here we go. Okay, so we're going to graph this one. The y-intercept is 3. Slope is 2. Remember, over 1. So I'm going to go up 2, 1, 2 over 1. Up 2 over 1, up 2 over 1. And then I'm going to do the opposite, which is down 2 over 1. And you see, that's what I'm talking about. When you graph these points, and that point exactly lines up with the other point, you know that I'm not having, this isn't an estimate of an answer. This is like the actual answer. So the actual answer is that ordered pair right there. So that's it. I don't know. I just like doing the points, because if I just kind of like did 2 and then made a line, there's a possibility that my line may not be as accurate as it needs to, and then I might think that I have an estimate. But when I do the points, I know that when I did the point here, that landed here. When I did this point, it landed right on top of that. So I know that my solution is not an estimate. It's exactly -1, 1. Okay? Yeah, I don't know about this. These 2 colors, they look like they blend too much. I'm going to have to go for a little bit more difference. I should have chosen a different one besides purple. But anyway, so that's graphing. Enough about color. Okay, let's go on to substitution over here. So we're going to substitute. Let's try this color. Okay. So this was graphing. Right? So it was, what was the idea? The idea was they're both solved for y, so let's just graph it, and that's nice. I don't have an estimate, I have an exact answer there. Okay, however, let's see this color, how this is. We're going to do this one through substitution. What do you think? I feel like this color is okay. It's like nothing fantastic. I feel like I should put a box around graphing over here too. I don't know. I mean, I guess it's growing on me. Okay, so they're both solved for y. Therefore, here I'll just write them really quick. Since they're both equal to y, that means they're equal to the same thing, so they can be equal to each other, right? Gosh, what's up with that 3? Okay, there we go. So I'm just going to set these 2 equal to each other. and then solve. Remember, whenever you have an equation that has variables on both sides, you want to get the variables on the same side first. And I always like to move this smaller. When you move this smaller, it ends up with a positive number. When you move the bigger one, you end up with a negative, right? If I go, this is negative x, right? And I subtract x, I'm going to have 2x minus x, which is a positive x. If I move this one and I go negative 2x, and then it'll be x minus 2x, then I'll be left with a negative x, and then I just have to remember all the negatives. So it's not like if you do one or the other, it's right or wrong, but you just stay with positive numbers. And I see that over the years, when people have positive numbers, they don't mess up as much as when there's like a negative and then they got to change the signs and everything, and then people mess up. Not saying that you couldn't do it. I totally believe that you could, but I just try to come up with ways to come up with the right answer as easy as possible consistently. And so that's a particular way. I don't always do it, but for the most of the part, like 95% of the time, I always move the smaller out of the two variables. So that's going to cancel. We're going to have negative 1 equals x, or x equals negative 1, which is perfect because that's what we have up there. And now we just need to figure out what the y is. So I'm going to put it in this original equation and stick in negative 1 plus 2, and I have y equals 1. So there we have it, and I have the same solution through substitution. Okay, perfect. Okay, let's look at a couple other examples. Let's look at this one. Okay, what do you notice about this one without looking? So we have y equals 3 minus x, 2x minus y equals 6. So would this be easiest to solve through graphing, substitution, or elimination, and why? See, I see this one solved for y, but this one is not solved for y. So I would say it's not going to be easiest through graphing. I could, right? It's possible. I just have to solve this for y. But this one's solved for y, and so I think this would be substitution. Definitely substitution. Okay, this is just going to be like a color parade. I'm just going to figure out all these colors and then see which ones I like. Okay, so this is equal to y, so I'm just going to substitute this in here. And we have 2x. Ooh, that's a nice color. I'm substituting this in for y, so remember you have to put it in parentheses. Equals 6. And then remember, whenever that negative is on the outside of parentheses, you have to distribute to both things. So it's going to be 2x, negative times 3 is negative 3. Negative times a negative is a positive x equals 6. And then we combine like terms, so 2x plus x is 3x. Minus 3 equals 6. And then just solve for x, right? That cancels. 3x equals 6 plus 3 is 9. We're just solving for x. Okay, boom, there we have it, right? X equals 3. And then we need to figure out what y is, so I'm going to substitute it back into this equation here. 3 goes in here, so we have y equals 3 minus 3, right? And then that's just y equals 0. So we have our solution there. 3, 0. Okay, perfect, perfect. All right, let's look at this one here, this example. So what do you guys think? We have negative 2x minus y equals negative 5. 3x plus y equals negative 1. What do you see? Graphing, substitution, or elimination? So I think graphing is totally out because neither of these are solved for y. Substitution is possible, right? It's not like either one of these are solved for y, but this is a positive y. Well, and this is a negative y, right? But this one would be easier to solve for y. We could just go minus 3x to both sides, and boom, there we have it. However, what I do notice is the equations have the same variable y, with the same number in front, but they're opposite coefficients, right? So there's a 1 here and there's a 1 here. Like whenever there's nothing, there's a 1, right? But it's a positive 1 and a negative 1, so we know that that would eliminate out pretty easily. So this would be an obvious example that we should use elimination. So let's just go ahead and do that. I'm going to go ahead and write this down first. Ooh, this is like a dark purple. 2x minus y equals negative 5. 3x plus y equals negative 1. And then, yeah, we just add, right? So those are going to cancel. And then negative 2x and 3x is x. Oh, this one's so easy. Negative 5 minus 1 is negative 6. And boom, there we know, we know what x is. And then we just need to substitute that into one of the equations. I'm going to choose the one that has y. So just go ahead and write that original equation here. 3x plus y equals negative 1. Substitute negative 6 in for x. And then what do we have? 3 times negative 6 is negative 18 plus y equals negative 1. Add 18 to both sides, and then there we have it. Boom shakalaka. Negative 1 plus 18 would be a positive 17. And there we have our two answers. X equals negative 6 and y equals 17. So our solution through elimination is right here. All right, there we have it. So those are just a few examples that I went over with you. Now we're going to go over some examples that I'd like you to kind of try on your own. So let's start with the first 1, 2, 3. So here's my friend Pause Dragon. Remind you to pause your device. Go ahead and work out 1, 2, 3. Make sure you try to figure out to use the best strategy, whether it's graphing, substitution, or elimination. When you get done, go ahead and press play, and we'll go over these together. All right, see you in a bit. All right, we are back. Let's go ahead and see how you did. You know what? I don't have my light on. I need my light. Just there we go. Perfect. Okay. So for this first one, what did you guys choose? Well, I would have chosen, since they're both equal to y, to graph it. So let's go ahead and let me get my light just right. Okay, it's kind of still in the way. All right, so let's go ahead and graph this first one. We know the y-intercept is 4, so that's right here. And then the slope is 1, so it's up 1 over 1. Just going to make all these nice little dots. Okay. Dot, 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 dot. Okay, and then connect the lines. It's nice to use a straight edge when you're doing these. Okay, and then let's do the other one. Graph the other line. I'm just going to use a different color. I'm going to try out orange. Okay, so the y-intercept is 1, which is here, right? Okay, and then the slope is down 2 over 1, down 2 over 1. And really, it's not, it's going to be up here. So we're going to do the opposite, which would be up 2 over 1. And boom, there we have it right there. And you see, it's an exact solution, which is super nice. It's not an estimate because there's one point that landed directly on the other point. So I'm just going to draw my line here. And then just go ahead and identify my solution. That orange is kind of nice. It shows up good. What's my solution? My solution is negative 1, 3. So solutions here, negative 1, 3. X is negative 1, 3. Perfect. Okay. I wonder if any of you tried to solve it through through substitution. Let me check that just in case any of you did. So with the substitution, you should have, they're both equal to y, so you'd set them equal to each other, right? And then move the smaller variables on two sides. I'm just going to do it really quick. That's going to be 3x plus 4 equals, cancel 1, subtract 4. Got 3x equals negative 3. You got x equals negative 1, which is great. That's what we got there. And then you plug it in, and I'm going to plug it in to figure out what y is, right? To this one, this is the easiest of the two equations. And there we have it, 3. So we got the same answer, whether we graphed it or we use substitution, which you could use substitution as well, because they're both solved for y. So yes, there you go. So if you got that right, great job. Let's go ahead and see how you did on number 2. So here, I would have definitely chosen substitution because it's solved for y. So let's go ahead and try that out. So I'm going to take this and substitute it in here. So negative 2x plus x plus 3 equals negative 4. Now you might ask yourself, okay, you substituted x plus 3 in for y. Why didn't you put it in parentheses? Well, you put it in parentheses when there's a number in front of y or there's a negative in front of y. But when it's just like a positive 1, it doesn't matter. You can just substitute it in, because a plus times everything, everything's just going to remain the same. So, okay, then we simplify. Negative 2x plus x would just be negative x plus 3. And we're just solving to get x by itself. Now we have negative x equals negative 7. Now I see this and people think this is the answer, but x is not by itself. There's this negative here, okay? So you don't have the answer. You have to get rid of this negative. And how you get rid of this negative is by multiplying both sides by a negative 1. Now sometimes people divide by a negative 1, but I definitely think the higher you get into mathematics, it's easier to multiply by a negative 1 than it is to divide by a negative 1. So it's kind of just like, trust me, because I've done upper level mathematics. So this will be easy for you over the years and the higher you go. So negative times a negative is positive. Just take my word on that one. Negative times a negative is a positive 7. Okay, and then we just need to figure out what y is. So I'm going to use this equation here. Substitute 7 in. And there we go. We have our answer, which is 710. All right, there we go. Okay, on to 3. If you got that one right, great job. Let's see how you did on 3. So, for 3, definitely wouldn't graph it. Neither of these are solved for y. I could do substitution because this is just a positive y. Well, and this, so it'd be easy just to move it from side to side. However, the choice that I see would be elimination because we have y's. There's a 1 in front of both of those y's, and they have opposite signs. So it's same number, opposite signs. So it's going to be really, really easy just to use elimination. So let's just go ahead and do that. So if we eliminate, right, that cancels out, and we're left with 4x minus 2x, which is just 2x, equaling 10 plus 4 is 14. Divide by 2 to both sides, we get x equals 7. And then we need original equation, so I'm going to use the top. 4x plus y equals 10, and then just substitute that in. And I just think it's nice, like when you know 4 times 7 is 28, like what method is the easiest, like you're just able to solve these a lot quicker, which is kind of nice. What's that, like negative 18? So there is our answer right there. So 7, negative 18, and always for that ordered pair, put the parentheses around. That lets other people know that you're talking about a point of intersection or an ordered pair as a solution that has an x and a y. Yeah, so this would be easier. Like when that cancels and we can find x equals 7 so quickly using an elimination, like even if we did it with substitution, which you could do, it would just be a longer process. But sometimes substitution is the easier process. So it's just being able to look at it and really know, okay, which method should I use that's going to be the easiest for me? Okay, so let's look at these two here. 4 and 5, and I want you to just go ahead and make some decisions and try to solve those on your own as well. All right, we'll see you in a little bit and see how you did. When you get done, press play and we'll go over the answers. All right, we're back. Let's see how you did. So for this one, 4, I wouldn't have chosen graphing. This is one that probably I would do substitution and solve for that y and get that y by itself, and then substitute into this equation. I mean, I could do elimination if I take this top one and multiply it by, you know, like -5, then that would cancel it out pretty easy. So that would be another way of doing it, but I think I'll just use substitution. So I'm going to take this 2x plus y equals 8 and solve it for y. Okay, that's going to leave me with this. And remember, this is my first equation, right? So whenever you solve the one equation, you have to substitute it in to the second equation, which is this one right here. Okay, so now I'm just going to substitute that in here for y. And do the distributive property, right? What happened? Did I lose my 5 equals 5? Okay. 5 times 8 is 40 equals 5. Okay, then we subtract. Subtract 40. Okay, this is starting to look better. Get x by itself, so divide by -7 to both sides, and we end up with x equals a positive 5. Okay, that is great. And then I just need to figure out what y is. I'm going to go ahead and substitute it into this equation. And usually I go this way, but I'm going to actually solve it using elimination, so I'm going to need this space. So I'm going to just kind of go this way, which is not something I typically do, but just for this problem I'm going to do that. So there we have it. I'm going to substitute the 5 in for the x. And that leaves us here. Boom. Okay. So we have the answer 5, -2. Perfect. So this was with substitution, right? But remember how I talked about elimination? Let's just go ahead and compare. I'm going to solve it using elimination too. And maybe some of you have solved it with elimination. So let's just kind of compare and see what's faster. Okay, so I would say with this first equation, what I would do is multiply the whole thing by -5, right? Because you need same number, opposite sides. So -5 times 2x is going to give me a -10x. -5 times positive y is going to give me a -5y. And that's going to give me -40. Then I'm just going to write this equation underneath it. Okay, these cancel. That's going to give me -7x equals -35. And if you see, we're really right where we were, right here, right? They're the same. So it looks like we're getting there a little quicker using elimination with this one. And then we have x equals, that's going to be 5. So, and then we just, write that same equation again. plus y equals 8. Substitute 5 in there. We get 10. Subtract 10. We get y equals -2. So you get the same answer, right? Two different ways. And you just, you know, I would probably say with this one, I think that it was easier to get to find the answer through elimination. Just barely. It seems like it was less steps. So, but either would work, right? I could see either way. Okay, let's go on to 5. How did you do this one? I think it would be pretty obvious to say that this one should be done through substitution, right? So I'm just going to take, this is what x equals. I'm going to substitute this in for x. Notice that in front of x it's just a +1, so I don't really need to use parentheses. I can just directly write that in. So y minus 1 plus 2y equals 8. Combine like terms. 3y minus 1 equals 8. And then we're just doing algebra, right? Y equals 3. Then we just need to figure out what x is, so I'm going to substitute it into that first equation. 3 in for y, and we get x is equal to 2, and so our answer is 2, 3. So if you got that one right, yokonekimashita, you did a great job, and I will see you in a little bit for Chapter 5, Lesson 4.